Let's talk about solving equations. Now, up to this point, we understand that our strategy for solving equations is to perform operations that will allow us to isolate a letter on one side of an equation or the other. And the operations that we perform are those which are the inverse operations of the ones that we see. If we see add 5 on one side and we want to get rid of that 5, we subtract 5. We do that inverse operation on 5 in order to eliminate the 5. Here's what I'm talking about. We have x minus 4 is 8. If we want to isolate the x over here, we have to get rid of this subtract 4. The inverse operation is adding. So we would add 4 on both sides to clear this minus 4. Now, the idea is that if we identify in a problem that we need to add 4 on one side for a certain purpose, then we simply need to add 4 on the other side to maintain the balance of the equation. And that's the whole idea. Here we bring down the left side and add 4. We bring down the right side, add 4. The 4's add out. You see, negative 4 with positive 4 is 0. So we have x, and 8 and 4, 12 on the right. The nice thing about solving equations is that we always know whether or not we have a solution because we can check. And we check by replacing the letter with the number we find for it. We find here that x is 12. So if x is replaced with 12 in the original equation, let's see if we don't get a true statement. We'd have 12 minus 4, 8 over here. 8 equals 8. Yes, that's true, so this is the correct solution. All right, if we see add 5, you see x plus 5. We want to eliminate that 5 to isolate the x so that the equation tells us the solution. And to eliminate or to clear the add 5, we subtract 5. We perform an inverse operation. So subtracting 5 on both sides means we bring this down, subtract 5. Bring this down, subtract 5. Perform the indicated operations. These go out, leaving x. On the right, 3 minus 5 is negative 2. We can check by replacing x with negative 2. Negative 2 plus 5 is 3. 3 is equal to 3, so a correct solution. And in a similar way, 4x equals 20. What we're seeing here is 4 times x equals 20. We would like to eliminate the 4. We see that the 4 is multiplied here, so we divide to eliminate it. We perform that inverse operation. And to show what we're doing, we bring down this side and show the division of 4, bring down the right side, and show that we're dividing by 4. We do the same thing on both sides. The 4's go out here, leaving x as expected. 20 divided by 4 is 5 on the right. Now, here's another situation, very similar to the others. We have x divided by 5. X over 5, you see, equals 3. Again, the idea is to isolate the x and make the equation tell us the solution to the equation. We can isolate that x by performing an inverse operation. The inverse operation of division is multiplication. So we'll multiply on both sides by 5. Now we can show that multiplication of 5 in a couple of ways. One way is like this. We just say 5 times this and 5 times that. Okay, 5 times x over 5, 5 times 3. You see, and it doesn't matter which side of the parenthesis the 5 is written on. The 5 could be written on this side or this side. It doesn't make any difference. 5's go out and we have x on the right, 5 times 3, 15. Let's check. If x is 15, we have 15 divided by 5. Oh, that's 3. 3 equals 3. X equals 15 then is a correct solution. All right, now consider this problem. The equation solving, this kind of equation solving, becomes a little more complicated when there's more than one operation to perform. And here we have that situation. We have 3/4 times a. Now we can think of this as we can perform a single operation to isolate the a if we realize that we can take this fraction of 3/4 and multiply it times its reciprocal. Now, a fraction times its reciprocal is 1, and so we'll be clearing the 3/4 if we multiply by the reciprocal of 3/4. The reciprocal of 3/4 is 4/3, so we would show it like this. It's 4/3 times 3/4 a. You see, and 4/3 then times 12. You see, we just show that we're multiplying the same amount on both sides. A fraction times its reciprocal, cancellations all around, it leaves a, and now 4/3 times 12. Remember, this is 12 over 1. 3 into 3, 1. 3 into 12, 4. 4 times 4 is 16. So a equals 16 is the solution. We can check it rather easily by replacing a with 16 and verifying that 12 equals 12. but it's a correct solution. Now, let me show you another way to approach the problem. We multiplied by the reciprocal here, but a lot of times we can't just take a single fraction or a single number and just have a very simple reciprocal to multiply by. Sometimes that's the case, but it's not always the case. And here's another strategy to use on equations having fractions in them. The strategy is a little more general than a specific idea of multiplying by a reciprocal. The general idea is clear the fraction or fractions first as a first order of business, and then clear the other elements that are involved in the problem. Here's what I'm talking about. We might think, well, gee, we have a fraction involved. We can clear that fraction by eliminating the denominator here. As a matter of fact, to kind of emphasize it another way, I can write 3/4 A as 3A over 4. And I can do that because, remember, A is like A over 1. I can think of it like that. And 3/4 times A over 1, 3 times A, 3A, 4 times 1, 4. All right, now let me clear the 4 here. You see, and then I'll clear the 3. To clear the 4, or to clear any fraction or fractions in an equation, you identify a common denominator and multiply through by that common denominator. The common denominator here, the only denominator, is 4. So we'll multiply by 4 on both sides. And the 4's go out here. We have 3A then is equal to 48. And now it's a problem like one of the ones that we've seen in the past. We'll get rid of the 3, which is multiplied times A, by dividing by 3 on both sides. So it's 3A over 3 equals 48 over 3. The 3's go out here, and we find A to be 16 as expected. So it's the idea of clearing the fraction by removing the denominator first and then dealing with the leftover number wherever it might appear. All right, consider this one. We have 6 equals negative 3C over 5. Now, let's back up to this problem. I do want to emphasize something a little bit more here. We changed this 3/4 A into 3A over 4. And it's also possible to go from 3A over 4 to 3/4 A. These are interchangeable forms. And a lot of times, it's necessary in mathematics that when you see this form, you want to use that form. And when you see this form, sometimes you want to use that form. So we have to freely be able to go back and forth between these two. Over here, for example, we could kind of separate the C, the letter, from the number part by thinking of this as negative 3/5 times C. You see, we could kind of separate the C sort of over here. And I'll show you that kind of strategy in a minute. But let's take let's go through this by clearing the fraction first of all, by eliminating this as a fraction. And you do that by eliminating the denominator. And to do that, you identify the common denominator. The only denominator here is 5, so we'll multiply on both sides by 5. We have 5 times 6. And on the right, we have 5 times negative 3C over 5. So 5 times 6, 30, and on the right the 5's go out and we have negative 3C. And now we can divide on both sides by this number next to the letter, and that number is negative 3, and I'll show that it's being divided on both sides. So let's see, on the right, negative divided by negative, of course, is positive, and the 3's cancel, so we have C, which is what we wanted to have happen. Positive divided by negative is negative, and 30 divided by 3 is 10. So negative 10 is our solution. And again, we could go back and check to verify that it is a solution, but it does turn out to be so. Now, let's take a faster way. Let's go through this a faster way. And we can use a faster way here because of the sort of peculiar and somewhat unusual situation of having a single fraction times a letter. And I showed you kind of a general way to approach it a moment ago by clearing the fraction, multiplying through by a common denominator. Now let's take a real fast track here. We think of it like this, negative 3/5 times C. You see, and now what I want to do is multiply by the reciprocal of this number. The reciprocal is just the same fraction flipped over. Don't forget, though, that the minus sign has to sort of carry forth, and we have to think about a sign pattern that's going to produce a plus c on the right and not a negative c on the right. That just means that we're going to multiply by negative 5/3, the negative, you see, of the reciprocal of this. So it's negative 5/3 times 6. And on the right, negative 5/3 times negative 3/5 c. And everything's going to clear on the right. And we'll go through that multiplication in a moment. But think about 6 as 6 over 1. 3 into 3, 1. 3 into 6, 2. So we have negative 5 times 2 is negative 10. And on the right, negative times negative is positive. The 5's cancel, the 3's cancel. When the smoke clears, we have 1. 1c is simply c. So c is equal to negative 10 any way we look at it. Here's another one. Y plus 2/3 equals 3/4. Now, it's a rather simple equation. And once again, there are a couple of ways of thinking about how to go through to a solution. I like this one. I'm going to show you the one that I like the best, and I'm going to show you kind of a shortcut because this particular one is just easy to work because the numbers are so small. But I want to show you a way that we're going to approach the more complicated problems and make that the primary way of approaching these for your homework. And that primary way is to eliminate the fractions in when an equation involves fractions, eliminate the fractions as a first order of business. And to do that, identify a common denominator and multiply through by it. Now, that common denominator here for 3 and 4 would be 12. So I'm going to multiply 12 times every term. So it's 12 times y plus 12 times 2/3 equals 12 times 3/4. Now, this kind of strategy is going to be brought to bear on much, much more complicated kinds of problems involving fractions. And that's why I'm showing it to you here. So here we have 12y, and then 3 into 3, 1, 3 into 12, 4. 4 times 2, 8. On the right, 4 into 4, 1, 4 into 12, 3. 3 times 3, 9. And now I want to clear the 12 and the 8. And I'll clear the 8 first. You clear the single numbers and then the number next to the letter when there's a choice between the two. And we haven't had much of that in the past. But we clear the 8 first, and we do that by subtracting 8 on both sides. So we have 12y plus 8 minus 8 equals 9 minus 8. And now the 8's go out, leaving 12y. And on the right, 9 minus 8 is 1. And dividing on both sides by 12, you see our object here is to isolate the y. So we show that we're dividing on both sides by the 12. These cancel, and y is 1/12. Okay. I'll show you another way to work this particular problem because the fractions are so small. We can take the approach that we have a letter that's almost isolated right now, and we just have a number that's added to it. And we can isolate the y on the left side completely by subtracting that number on both sides. All right, that is, we can say, let's just take 2/3 from both sides. So let's take y plus 2/3 and subtract 2/3. And then on the right, take the right side and also subtract 2/3. You see, and now 2/3 minus 2/3 is 0, and we have y on the left side. And now all we have to do to find the value for y is to simplify over here. Now, the simplification process, though, involves finding a common denominator. It's pretty easy in this problem, though, because between 4 and 3, 12 would be the common denominator. So we change the fractions into so many twelfths. 4 into 12 goes 3. 3 times 3, 9. And here, 3 into 12, 4. 4 times 2, 8. So 9/12 minus 8/12 leaves 1/12. So y then is equal to 1/12 as expected. By the way, before we actually leave this problem, I want to mention to you about how you make fractions, how you structure a fraction. There is a tendency to write fraction bars like this 8/12. There is a tendency to write it like this. It's kind of fancy. It looks a little looks nice. It's kind of the way that you would have to do this if you were emailing or using a typewriter or something like that. If you're using a keyboard, you almost have to use this because of the slash, and you're writing on a single line and all that kind of stuff. But if you're using pencil and paper, I strongly suggest that you use a horizontal fraction bar like this. And the reasons for that are many, but they all have something to do with organization. You can more easily see multiplication of fractions as going straight across. You can see clearly your numerators and as distinct from denominators in this situation if you were multiplying, you see. And that's a very important idea. If you have a slash like this, then you can't see them as easily, and it uses up more brain power and exhausts you faster to have to interpret that kind of thing. So I strongly suggest this way of writing fractions. Let's look at a couple of word problems. 3/8 of a number is -1/4. Find the number. Now, a lot of times to solve word problems, all we do is go through a little word interpretation. We take the words involved in the sentences and we interpret them in a mathematical form. And that's all we really have to do here. 3/8 of a number. Of means times. 3/8 times a number. Times a number. Let's let a letter stand for the number. Let's let the letter be, oh, I don't care, n. 3/8 n means is equal to -1/4. -1/4. See, that's all there is to it. And so it's just a direct interpretation of what we read. We write this in a mathematical form, and now we solve the equation. Now, to solve this equation, the fast way is to just multiply over here by the reciprocal. The reciprocal is 8/3, so I'm multiplying on both sides by 8/3. And away we go. The 8's go out, the 3's go out. We're left with n as expected. Now let's see, negative times positive, negative. And then, let's see, 4 and a 4, 1, 4 and a 8, 2. So we have 2 times 1, 2 for the numerator, 3 times 1, 3 for the denominator. Oh, -2/3 is the answer. And again, we could go back and interpret this in terms of what we have. We could say, oh, 3/8 of, now the number we found is -2/3. 3/8 of -2/3 is -1/4. And we could actually go through and take 3/8 of, or 3/8 times -2/3 to verify that it does indeed give us -1/4. But it will. Now, here's another. By the way, as we go through problems like this, and in fact any of the problems that you see on the board, and I failed somewhat to mention this before, but as you look at a problem on the board, if you have a pretty good idea of how to work the problem, it's a good idea to copy the problem onto a piece of paper and then stop the tape, try the problem on your own, and then roll the tape to verify your solution. Gives you a little bit more practice on these rather than just kind of looking at the solutions. All right, here's a pretty good one to do this with. 1/3 of all the sugar produced by Sinclair Refinery is brown sugar. This year, Sinclair produced 250,000 pounds of brown sugar. How many pounds of sugar were produced by Sinclair Refinery? How many total pounds of sugar, brown and otherwise, you see, is what this kind of implies. Now, the word interpretation idea kind of gets fuzzy here, doesn't it, with a problem like this? Because what words are we going to interpret? Well, we sometimes have to paraphrase the way that we understand a problem in order to write a sentence that will translate into a mathematical form for solving an equation like this. Now, here's what we know about this problem, just by the way that we read it. It says that 1/3 of all the sugar produced is brown sugar. Now, we can just about take that. Let's see. 1/3 of means times of all the sugar produced. And we're looking for all the sugar produced. So 1/3 of some unknown quantity is equal to the amount of brown sugar, you see, is what this is. So I'm interpreting this almost directly. But I could write a little sentence down here and say 1/3 of all sugar is brown sugar. And now interpret this mathematically. It's 1/3 times x means is equal to the amount of brown sugar. And we're told that this year the Sinclair produced 250,000 pounds of brown sugar. So the amount of brown sugar is 250,000. You see, so here we have a mathematical sentence corresponding with this English sentence, and we're going to solve the mathematical sentence, the equation. And sure, we could have come up with this same equation using that sentence, but this one is a little bit easier. And I think it's important to get into the habit of either paraphrasing or simplifying an English sentence or phrase in order to get to a mathematical form. All right, let's solve the equation. To do that, we'll clear the 1/3, and we clear 1/3 by multiplying by its reciprocal, which is 3. So we're multiplying by 3 on both sides. Threes go out here as expected, so we find x to be 3 times 250,000. Let's see, that's 750,000 pounds of sugar was produced overall by Sinclair Refinery.